Hello students. Today we are going to continue our topic about chemical reactions. I want you all to open your books page 545. In a math equation, the left side must equal to the right side. How does the left side of a chemical equation compare to the right side? The total mass of the reactants equal the total mass of the product in a chemical reaction. This law is the law of conservation of mass. In the law of conservation of mass, it states that the total mass at the reactant side, the total mass of the reactant side and the total mass of the product side should be equal. The reactants and the products we have discussed in our previous video. The total mass of the reactants, which are usually on the left side, should be equal to the total mass of the products, which are usually on the right hand side. This law is called the law of conservation of mass. In other words, the total number of each type of atom must be same in the reactants and the products. For example, it means that the total number of atoms of one element at the reactants should be equal to the total should be equal to the number of atoms of that element at the product side. The number of atoms of each element should be equal at the right hand side also and at the left hand side. For the water forming reaction, the number of hydrogen and oxygen atoms are the same on both sides of the equation. See, we have this equation of water, hydrogen reacting with oxygen and forming water. So now the total number of hydrogen atoms here are 2H2, means 2 multiplied by 2, 4. And here at the product side, 2 multiplied by 2, it's 4. Now how many atoms of oxygen are here? O2, it means 2. And here oxygen, this 2 is with H also and with O also. So 2 multiplied by 1, 2. So number of atoms of oxygen at the reactant side are 2. And the number of atoms of oxygen at the product side, they are also 2. So we say that this equation is balanced. The number of atoms of hydrogen at the reactant side is equal to the number of hydrogen at the product side, and same with the oxygen. Math equations make sense whether you read them right to left or left to right. Chemical equations are similar. Most chemical changes are reversible or they can be undone. Means most of the chemical reactions, they are reversible. Either you read it from the right side or from the left side, they are the same. When a chemical reaction is reversed, the products break apart or combine to form the original reactants. Water can be broken down into hydrogen and oxygen gas. Now here they say that there are some reactions that they can be reversed. Instead of writing equation like this, 2H2 plus O2 is equal to 2H2O, it can be reversed. It can be 2H2O will be equal to 2H2 and O2. It means here we are combining, here we are reacting hydrogen with oxygen and we are getting water. In the reverse reaction, water can be broken down into hydrogen and oxygen. If you see the equation above, here we have sodium bicarbonate, NaHCO3. Sodium bicarbonate is reacting with acetic acid. This we have done in our previous video. Sodium bicarbonate, NaHCO3 is reacting with acetic acid, HC2H3O2. What we get? We get H2O water, we get carbon dioxide CO2, and we get sodium acetate NaC2H3O2. Now if you see the total number of sodium atoms, how many? Only one here at the reactant side. At the product side, it's only 1. So sodium is balanced. For example, if we see oxygen, oxygen 3 and 2, 5 here. So oxygen 1, 2, 3, 4, 5. So in this, and we can see the hydrogen and carbon also. Hydrogen here 1, 2, 3, 4, 5. Hydrogen here 2, 3, 4, 5. Carbon here 1 plus 2, 3. Carbon here 1 plus 2, 3. So in this way we say that the equation is balanced. We move on to the next page. Here we have a topic: how can you spot a chemical change? How can you spot a chemical change? Chemical changes produce new substances. These substances have different properties than the previous ones. Means when chemical changes happen, a new thing, a new product is formed, and that new product will have properties different than its original reactants. Often you see, hear, or smell the formation of new substances as a chemical change when a chemical change occurs. When a chemical change occurs, usually we can see the chemical change, we can hear it, or we can smell the formation of new substances. A change in color is one sign of a chemical change. So when there is a color change, we can say that there is a chemical reaction. It is one of the sign. Color change is one of the sign of chemical reaction. When bleach whitens a piece of cloth, it does so by chemically changing the dyes on the cloth or the cloth itself. Means when we put some bleach on paper, we put some bleach on the cloth, it whitens the cloth. So the color is changed, we say it's a chemical reaction. Chemical changes form layers on metals and often dull their color. Sometimes what happens, due to chemical changes, a new layer is formed on the metals. A new layer is formed on the metals which dulls its shine, which dulls its color. Rust, for example, is reddish. While the iron from which it forms is shiny. Rust Rust is when iron reacts with oxygen in the air and it forms a reddish brown layer on the surface of the there is a reddish brown layer on the surface of the iron. Now that is reddish brown and it's very dull, but the iron itself is shiny, so it dulls the shine of the iron. In fact, when metal corrode, it is due to a chemical change. When any metal corrode, when corrosion happens, we say that it's a chemical reaction. When corrosion of a metal causes a color change, it is called tarnish. When due to any corrosion, the color of the metal is changed. Due to corrosion, the color of the metal is changed. We say this tarnish. When you place an antacid tablet in water, chemical reaction occurs and bubbles form. The appearance of bubbles is another sign that a chemical change has occurred. Means when you put something in water or in some acid, bubbles are evolved. So we again say we say that this is a chemical reaction. That like when we put antacid tablet in water, so many bubbles will come out. So that's a sign of a chemical reaction. Do you recall what happens when baking soda and vinegar are mixed? This we have done in the previous video. When we put vinegar in baking soda, what happens? So many bubbles come out of carbon dioxide. Bubbles of carbon dioxide show that a chemical change takes place there too. Now at the bottom of the page, you have three pictures. This is the first one. Bleach removes the color from clothing by means of a chemical change. There is some bleach on the blue shirt. Now it is whitened. So we say the color is changed. We say this a chemical change. The silver in this spoon reacts with oxygen or sulfur to form tarnish. See this. brownish material. This is tarnished. So again, this is a chemical reaction. In the third picture, as an antacid acid reacts with water, bubbles of carbon dioxide gas form. Now see, the bubbles are coming out from it. So we say that it's a chemical reaction. On the next page, we have chemical changes can produce more than just gases. A participate is a solid formed from a chemical reaction of some solutions. Now, what is a participate? It's a solid. It's a solid that is formed from the chemical reaction of some solutions. There are some solutions when they chemically react, a precipitate is formed. A very thin solid is formed. For example, when a sink is not cleaned, it may develop a sticky white layer. When the sink is not clean, it will develop a sticky white layer. What's that sticky white layer? It's soap scum, and it is a precipitate which is formed from the solutions of soap and water. Okay. Some chemical changes involve the release of light and heat. Now there are some chemical changes in which heat and light is produced. Heat and light is released. When heat and light is released, again we will say that it is a chemical reaction. It's a chemical change. A burning candle, for instance, produces a hot flame. When we burn a candle, it produces a hot flame. The heat and light come from the combination of atoms in the candle and the wick from oxygen and the wick with oxygen from the air. Now what happens when we burn a candle? We get heat and light. From where it comes? It comes from the combination of atoms in the candle and wick. When the atoms in the candle and wick, they react with oxygen from the air, so the candle burns. So we say that it's a chemical reaction. If a chemical reaction releases energy, then reversing that chemical reaction will absorb energy. Like if there is a chemical reaction, energy is released from it. It's releasing energy. So if we reverse it, before it was releasing, so now it will absorb energy because the reaction is reversed. Here a picture is given, two pictures are given. See, forms are precipitate. See this yellow material, this is a precipitate. This is called precipitate, and this is the candle, burning candle. It is releasing energy. Class, I am stopping the class here. Inshallah, from the next page we will continue tomorrow. Thank you.